Alright, right now I am doing a reassessment on the chapter 14 through 18 test, the midterm that we did. Just going to go over the problems. And so we are trying to figure out the magnetic field at C from this charge Q right here. It's a proton. So that is the value for that. I put the location is 5e to the negative third, comma 6e to the negative third, and 0. The velocity traveling away from the charge. The radius, which I took from here. The magnitude, which I did these two squared plus each other under the square root, and then I put the r vector on top over the r magnitude to get the r hat, and this is the formula for magnetic field, and I plugged it in. So that is number 1. Number 2, I put that the arrows that the electric field would be moving this way, but it would get weaker and weaker as it went to B. I'm sorry, I marked that out right there. And I put from it, you asked the question, and I put VB minus VA. It would be negative because the magnitude of A is much larger than B, and so final minus initial B minus A. Since your A is larger than your B, you would end up getting a negative value. For this one, I put my change in voltage right here, and the electric field, and the change in current, and my H up here over my H constant over my 4 pi epsilon naught times 1 over x to the 4th from B to minus A, like up here, and this is the equation I got for it. Sorry, I have to put another bracket right there, but that's going to be negative. Let's see, number 3. For number 3, I got the electric field would be Q divided by A over 2 pi epsilon naught, 1 minus x over r, where x is less than r, and then the derivative of E, which is dq 2 pi r squared, e to the naught, 1 minus A minus x over r, this is your A, and dq equals q over L dx. And then again, I took that further and added the L from that, from the dq to q over L. Kept that as is with the dx, and then this is the integral would be q over, these are all constants, and then it's L 0 to L, 1 minus A minus x over r dx. I couldn't figure out a third way for this, but the first way is the electric field equals 1 over 4 pi epsilon naught Q over RL, negative A, 0, and 0. And then for this one, the integral of A would go to infinity, the field would go to 0, and that's the reason how to check it. And for the last one, for this field, since it is a neutral insulator, the field can't be on the outside, it's going to be on the inside, and since they all make little dipoles in here, but they can't move around, so that's why you have this negative on the left and positive on the right. As far as this goes, since this is a metal sphere, you have protons on the outside collectively together because of the dipole. Positives want to go to negatives, and then the negatives want to go to the positives. If you asked about B, which is the center due to the dipole, and you would have it going this way because of the negative, and on the circle it is going towards the left, so that's why you see that as is, and then your E net would be 0 because they would cancel out. Thank you.